G'day guys, got this, what is it, a GP 3000's come in for repair. It was completely blown up on the input stage. It took everything out. It's quite amazing actually. It took out the two N-channel MOSFETs that lived here. It took out one BAV 99 diode, which I've actually replaced that. It took out whatever it is, BC 857 there. I've got those two MOSFETs there. I've got them in the anti-static packaging. For reasons, I'll get rid of that. I'll flip it over. You gotta be careful with these. Okay, and if you can see here, it blew up one of the op amps, and it blew up the BF 908, and it blew up both of the P-channel input FETs, and it also blew a BAV 99 on this side of the board. Actually, I should just stick my head in the camera there to make sure that what I'm poking is that you can see. Yeah, I think so. You might have to blow it up. I don't want, if I zoom in too close, then if I move the board, you won't see what's going on. And I'm not staring at the back of the iPhone to see what's going on, so you won't, it'll go pear-shaped if I zoom in too much. And if I'm holding the phone zooming in, I won't be able to hold anything and won't be able to work on anything. So that's how it'll go. So yeah, this is the poor old thing. Even you can even see here that the input N-channel MOSFET, it's only, where am I? See, I've got to lean my head back and look in the back of the camera and see where I am. Even that N-channel switching, that switches the detector on and off, so you don't burn out the switch. It's just the switch controls the gate of that little MOSFET there. That just turns on, turns the detector on. Just basically a voltage follower type thing. And as you can see, I don't know if you can see, probably, where am I? In there, you can see it's brown on top. Yeah, obviously it tried to turn on with the whole input stage shorted out, so it didn't like that. So it did survive, but I'll replace it anyway, because knowing my luck, if I don't, it will eventually fail. It's probably had a lot of its internal cells cooked, and it won't be able to switch properly, and there'll be probably a decent voltage drop across it. It will eventually chew out. But on here, I'll tell you what I found. I found this on these detectors, that I had them on top and I flicked them off. These are 2SK1334 MOSFETs that you can't readily obtain anymore. They stopped production, and for these detectors, it is one of the best low ohmage, low capacitance MOSFETs that you can get. You start using even better MOSFETs that have better or lower on resistance. They tend to have higher capacitance, gate capacitance. They're slower to drive within reason. But the thing is, there is capacitive coupling from drain source back into the capacitance of the gate, and that's because you've got signals going through there, and it just squashes it out. So, in all reality, you wish you didn't have a switched MOSFET front end, but that only leaves you now with the old diode and resistor front end type to get rid of that flyback voltage. And suddenly you can't run low noise figure devices if you do that, because what's the use? You got the resistor generating a hell of a lot of noise, just broadband spectrum noise through the resistance, and you might as well, just use El Cheapo op amps on it, and then you get a performance drop. It's one of the reasons why Minelab do have a performance edge over other detectors is that so many other detectors out there just rely on a 1K resistor into a diode going to ground or return and burn up the flyback energy through that 1K resistor or part thereof, and just stop it getting into the front end, because you don't want flyback voltage into your op amps. That'll be the end of those. And then the diode stops conducting, and then receiver turns on. But your signal's still got to go through that 1K resistor. So it doesn't make sense to do it that way to me. It does work, but doing it this way, there's a performance bonus. And I actually came up with a way. Well, I did make a fully floating switching front end, but if you really want to make a really good front end for one of these, what you want to do is you want to have the front end direct connected, and what you'd probably do then is you would probably have a isolated subsection and not referenced to ground in any particular way. I know how to do it. I know how I would do it and retain the low noise figure, and I would basically direct connect in, and even with flyback going into that thing, the whole thing's isolated from ground at the flyback point of time, and it will not blow anything up. And after the flyback event, it's all got to come back and be ground referenced again. But there is ways of doing it. I've actually done it. It does work, but it's not for a design like this. It would be a redesign. So it will go into something else. There are other ways of doing it as well. There are methods of isolated supplies and then doing a photo optical conversion. But even so, you can, even doing video bandwidth, you're still going to get some noise. You won't get the performance that you are striving for with a direct connect and have it all under control. But anyway, what I was going to say about this, and I'll just make sure I'm still on it with the camera. This might sound really over the top, but it's not. These little MOSFETs in here, there's a particular way you have to handle MOSFETs, especially the smaller ones. Even if I don't care if it's got, gate diodes or whatever. For some reason, I've found this. If I manhandle MOSFETs, especially in winter, I'll connect them up and I'll go, yeah, they're okay. They've got internal protection. Nothing's going to happen. Hook them up, and I'll be testing a detector. It will be fine. And then, for no apparent reason, MOSFET will go short circuit. And I go, what happened there? I won't have any clue to why. I'll then take that MOSFET out that went short circuit. It's still switched by the same gating as the other one, because it just gate to gate. It's no big deal. Nothing fantastic. I'll check the wires. Nothing's come off and sparked. I'll just put the oscilloscope there and wiggle things around to see if I can generate any high voltage events. And no, can't. It's fine. So then I said to myself, well, the only thing I did was manhandle the MOSFET, right? So it could have had a static discharge. I'm a potential. I'm sitting on an insulated chair, I've got insulated shoes, and maybe I've touched it. And as I go to solder it or grounded soldering iron or whatever, it's discharged, it's pulled current through, done something, and the MOSFETs fail. Not straight away, but over time they can. And you don't know when it's going to fail. It might fail in 5 minutes or 5 months or 5 years. It's really roll the dice event with these things. I have had it happen, and it's not a regular occurrence, but it does happen. With MOSFETs, if you want to replace it on these, first of all, too, you have to discharge the capacitor here. If you don't, and you touch anything here, it will blow that transistor up again, that little P channel bipolar. But what I do with these, I get pointy tweezers. These have been cut strips, so I'll go in there and I'll just pop it off like so. And you know, you see people and they've got grounding straps and total overkill. But I can understand why people think it's necessary. But I've got this, and these little packages are meant to be dissipate static anyway, and that. But what you do, you got to keep everything at the same potential. So you got it in this hand, you know, that hand goes to that hand, same potential, and you can just pop it out on your hand like that. It's the same potential. It's not going to get a big static charge on it doing that. It's not going to blow up. Um, the only other thing you do is, like, you are all the same potential, and if you are worried that there might be some difference between across your body of some thousands of volts, which is highly, highly unlikely, because your hair would be standing on end if that was the case. Um, what you do to touch MOSFETs, touch the surface, touch your hand, whatever. You don't really need to do this, but I will touch my hand. Just make sure that this is now the same potential as that, and you just bang it on there. You can pick it up. You can do what you want with it. Now, the other thing I've done with doing MOSFETs, and I've checked this, and they never fail. I have never had them fail. You hold your MOSFET like so. You then rest your hand on the board like so, and then whilst you're touching the board, just keep it all at the same potential. There's no build up. It can't. It's impossible. You know, you might get a few millivolts, it's not going to do anything. But then you can hold it there if you want, and you can then hit it with the soldering iron. Also, with your soldering iron, just touch it to the board, touch it onto a negative point. Under this paint here is a ground point. You could probably touch it also there on the black wire of the coil as a ground point as well. It's not going to do anything. And if you're going to use that ground point there as well, make sure the coil's plugged in. No voltage, but because it loops through. It's got an isolated low noise ground connection there, and you do want to, or just jump a pin 1 to 5 together with a bit of wire or something if you want to. Or if you're not worried about doing that, you can then go off the sensitive isolated, or sort of isolated, separate low noise ground, which is the first pin there next to that first diode. That's the yellow wire on these detectors. But yeah, MOSFETs are interesting devices. If you don't handle them right, for some reason, they can blow up. I didn't touching this with my finger, and then I just drop it down. It's basically, you don't want to cause a bridge where it can go zap to any leg or anything like that. Just remember, when you touch it, you're touching things first, touch it. Whatever it's on, if you move it to a different surface, touch the surface whilst you're holding the MOSFET, which you've already touched the surface here. You know, if you want to pick it up and then you want to go touch and then put it there or whatever. Not that it's totally 100% necessary to be so pedantic, but don't pick it up and then go like this with the gate leg pointing down, which is the first leg, pointing down and touching the other board without bringing the two potentials together, because you will have a potential disaster. That's probably the meaning of the word. Now, I have to get my soldering iron, and I'm going to have to replace where it lived. There's one here and one here. So what I normally do with this, like I've already discharged that capacitor there. I don't worry about the 200 volt one. It makes a big bang if you discharge that one there of those 2 points. It's better off to have something like insulated probes and pointy sewing needles onto it, and something more like, say, a 250 ohm resistor, and just stab it through the paint, because you've got to go through the paint and discharge it. But this is live. I'm not going to touch it. There's nothing there which is around this part of the circuit, so I'm not particularly worried. I'd have to back feed for these diodes here, and it's not going to do that, so I'm not worried about it. You're more worried about this capacitor that sits there under the board, of course, but that's the legs to it. One, that's a ground leg there, which has this little wire runs off to the front end, and the other one there. And yeah, anyway, it's a 15-volt supply rail capacitor. It's the main capacitor for the 15-volt supply, and it basically connects onto this speed up transistor. Anyway, I'm not going to go into how that works. I'll be here all day, but that's what it does. It speeds up the discharge. So look, I was going to put a bit of blob on these. I don't want to put too much because these devices, they had different devices on some of these early detectors. I think they were, what were they? Something I can't remember the prefix of what it was, but it was I think it was a 214 or something. It's exactly the same transistor they're using as a damping MOSFET here, the one covered in white paint. It's a big package. It's a bit of a slug, and it has too much capacitance. And they were using these ones here, and later on they started replacing them with these 2SK 1334s. They're a much better device, and there was no provision to put them there. So what they do, or what they done in manufacture, they have basically just had it tacked on there, and it's got hot melt glue sitting there and there, and that hot melt glue held the back of them where they really should be on a heatsink of some sort, or a little bit of a board pad to dissipate some of the heat. They do get a little bit warm, but if you do pretty blobby solder on the legs, use that as your heatsink, as a heat path. Um, like I say, it's not the best, but what we're going to do now, I'm going to pick that up in these. I really want my bitey ones, and I can't spot them on the bench. So my bitey tweezers have disappeared. I don't like these because if you squeeze too hard, the thing shoots off it's like a pea shooter. It goes pyong, shoots off. So you don't want to do that. But what I'll do now, hand this, everything's on the same potential. Pick this up. This is metal. It's in my hand, and just grab the whole thing in the middle, like so. I don't like doing it with these tweezers. It's painful. It's easy to slip and the thing goes flying. So we'll give it a go. Now I've got my iron here, and definitely so. What I'll do, I'll just touch the earth point there, just in case there is a static charge. I doubt it, but we'll do it on here. We have to lay this back, or else it'll crash into the top of the board. You got to remember, this device wasn't made to go here. Then it's twisting around the soldering iron. Okay. I've just got it tacked there on the middle leg, so I don't need the tweezers anymore. Got the solder, put my hand on the board. Okay. Again, I get the soldering iron, just touch it there on the earth point, and get enough heat up there. I'm going to blob it because the blobs will act as a heatsink. Well, it will get rid of some of the heat. It won't allow it to build up on the device too much, or should I say in the device. The center part of these can get up to about 125 degrees Celsius in the junction. You don't want to exceed that. Not that that would be a good place to run them, but they can, and eventually you'll get metal migration, which the little tiny atoms of metal will move and eventually cause short circuits if it gets too hot over a long period of time. So that is connected. that's safe as houses now. That it can't do anything. So what we do, we just do the same thing. Actually, what I'll do, I'll just tin up the other, make sure the other side's tinned up enough. It is. Same thing. Open him up, get him out of his packet. I'm going to say this was just a taped reel. Get it there, get the potential the same. It's just a matter of just touching what it's on before touching it. It's always the safest way to do it. Turn it around. All the same potential again. It might sound really strange and weird doing this. If you're using JFETs or something like that, you definitely would do this because they don't have any protection. But I've got that now, like so. Hand on board. Just touch everything at the same potential. Doesn't make any difference. Get the soldering iron. Hands resting on the board, touching the metal, touching this. Get this. Just touch it there. Same potential, and I'll do the end one here because it's got a bigger blob. And what I'll do, I'm just going to push it over a little bit. I'm going to risk burning my fingers. Yeah, it came forward the wrong thing. There we go. Stay there. Okay. If you stand it up too vertically, it's going to bang into the case when you put it together. Got the solder in my hands, all same potential. Touch the board. It's all fine. Get a bit of heat in the middle leg. That's where the main part of the heatsink goes to the middle leg. So that's on. Now I have done the other side of the board. I have replaced all those blown up components. So just for fun, I'll stick it on. Oh, I've got the monocoil that I reworked and put those cores in. Well, we'll just try it on here in mono mode, and I'll just plug it all in, and we'll see if we make smoke or not. So turn the amplifier on, the preamplifier, which Chari's been making heaps of those today. There's a stack of them behind me. We have a big order. We sell these. We sell a lot of batteries and our boosters and things through. Oh, what does he call himself? Gold Rat up there in Queensland. He buys a lot of our stuff. Okay, this is the moment of truth. It'll either explode or it'll work. Let's try it and see what happens. Sounds like it's working to me. Let's get a small target. Well, I thought it was working. Sounds like it's working, but it's not actually working. Why is that? It didn't do that before. Okay. I have to flip it over. There is something else going on. That's all soldered on. That's connected. Okay. It's a job for the oscilloscope now. We'll find out what is happening here. Dear me, if I can get my lead untangled, it's going through so many wires on this bench. Every time you pick something up, put something down, move things around, it just tangles up everything. So you gotta be careful too, because it pull a wire, it'll pull your soldering iron out and it'll go on the floor and burn the carpet or something like that. But I'll take this over. There's an earth point there. I'll just check both of these inputs and I'll just see what's going on. I don't think I've got anything in the wrong position. Nah. Should just work. What's a bit high? 2 volts is a bit high for the input of the op amp. We'll go down to 10 millivolts. Okay. Okay, still got a problem. Let's make sure. Okay, I have to step that up a bit. What's going on here? Oh, okay. I can see at the bottom of the screen there. That channel there is still not working. Okay, still got another fault somewhere. Murphy's Law. One thing I should check, I'll just see if these are gating. So I'll better increase the volts. 5 volts a division. I'll use the earth point there. Okay, we'll just see if this thing's gating. Ah, it's not gating. Okay, that's the collector. That's the base held low. Dear. Okay. I hope. Okay. What it is? The gates aren't turning on and off. They're held down in the off position, so non-conductive position. That will be controlled by the ADG 333 on the other side of the board. And sometimes when these things blow up, even though the gate connection goes through a 100 ohm resistor, if it did get high voltage, it's just punched straight through. It'll just go straight into the ADG 333, and it will just take the switching transistor out of that and basically blow it up or do something. So I'll show you where that lives. Whoopsies. Get over there. Okay. I don't know if you can see the big fat chip there. I don't know if you can see that. It's just there somewhere. Um, like I say, it's very difficult to pick these things up with all the wires on it and get the coil off. Make that gone. Make that gone. Lift it up carefully. Don't bend these too much here. They will break and snap. If they've got thick paint on them, you've got to be very, very careful. They will just end up getting fracture points and break on those points. These are okay. They haven't got a lot of paint on there. But yeah, that chip there can be a problem. Any other componentry which is shorted, possibly. I didn't check the other BF908, and I didn't check that other BAV99 there either, because I actually did have, I checked this input here and I'd actually had signal. It's only since I have fixed up around here and then reinstalled that op amp that it doesn't want to do any gating, which is very strange. I don't know if it was gating in the first place. I didn't have the N-channel MOSFETs in there, so it might have been partially sort of working, but now it's sensed something and it's locked out. So I will have to work on that. I'm not going to make a video about mucking around. I'll be here for a while doing that. So it's just a matter of getting in there. You want to check too on these BF908s on the gating that if you look at these things here, pin 1 and 2 Pin 1 will be a constant voltage, 5 or 15, can't remember what it is off the top of my head. Pin 2 will be, I think it's 15 volts switched on and off. It's antiphase to the receiver, switching on and off. Pin 3 goes to the pin 2 on the op amp. Basically, it's got a resistor, and basically it shuts the thing up during the transmit cycle until the receiver wants to come on. It just keeps a little bit of constant current going through, because if the series MOSFETs from the receive side off the coil go open circuit, well, then this thing doesn't know where it is in space, so it'll fly up or fly down, so it won't turn on fast enough during the next receive cycle. So you hold the basically you're connecting, more or less connecting pin 3 and pin 2 together through a resistance and through that BF908, and then when the receive comes on, the BF908 turns off, and there's no bias between 2 and 3, and the op amp's free to get its bias and input signal through those series MOSFETs that go to the coil. So I could go on and on about this stuff, but I don't want to bore you, because I know, some people are interested, some people are not. There's probably 10 people who are really interested, and umpteen million that are absolutely not interested. So anyway, I'll get into it. I'm going to stick my head right in there and suss out what's going on. And you don't want to see the back of my head on the camera. So yeah, that's that anyway. Catches.